Welcome back. So in this video we're going to solve these questions concerning blocks placed side to side using the Newton's laws of motion. So I'm given a question here. Two blocks of masses 4 kg and 2 kg are placed side by side on a smooth horizontal surface as shown in this figure, right? A horizontal force of 20 Newton is applied here on 4 kg block. Find the acceleration of each block. Now you have to be very good at imagining things if you want to be good at solving a lot of physics or mechanics questions, right? So now you visualize this. Two blocks placed side to side on a smooth horizontal surface. This means there is no friction as shown in that figure. Now we need to find the acceleration of each block. I want you to close your eyes and imagine you have a 4 kg block and a 2 kg block placed like this, side to side, and then you apply force to them. Maybe just if you can't know, imagine applying like a 20 Newton force or any force to them. Okay, how will they move? Will they move together? Exactly, they'll move just as one thing, right? It's just like you are pushing two things at the same time, right? Yeah, for instance, I have this charger here and this pen here placed side to side. So if I push, they'll just go together as one thing, right? So that means this 4 and 2 will behave as a 6 kg mass, right? I need to find the acceleration in each block. That means the acceleration will be the same, so they'll have same acceleration. Let me call it A, right? Okay, now let me adjust this. Okay, same acceleration A. Now remember, in Newton's second law of motion, we said the net force equals to the rate of change in momentum, whereby net force, which is the sum of all the forces, equals to mass times acceleration. We need the acceleration. Now what's the net force? The net force is just 20 newtons, right? 20 newtons, the only force that's acting there, external force acting there. 20 newton. Mass, we're talking about the forces in this x direction, so it's good to put x, because some will start saying, I don't know, gravity and things like those, but those things do not affect this horizontal motion. Okay, what's the mass? The mass here is 4 plus 2 kilogram, right, which is 6 kilogram. Let me put newtons here, times the acceleration A, which I'm looking for. So acceleration is simply equal to 20 newton divided by 6 kilogram, whereby you get our acceleration as 10 on 3 meters per second squared, because newton is just like kilogram meters per second square. Okay, so that's our acceleration. Now we also need to find the normal reaction between the two blocks. Now again, I want you to imagine you are one of the boxes right now. Imagine you are this 4 kg box, right? Okay, yeah, you are this 4 kg box. Maybe you are with another person weighing 2 kg, right? Then you are being pushed to 20 newtons. Somebody is pushing you, but there is someone here who is obstructing you, like, hey, move it, somebody is pushing me. Like we're in a long queue, placed side to side, then somebody is pushing from behind. You'll be experiencing two forces, right? The person pushing you, this 20 newton force, but this one, it's like stopping you from moving. It's like it is like applying a force, like a reaction force. Remember the Newton's third law of motion, we said in every action there is equal and opposite reaction. Okay, now let's solve for B. Let me put a line here. We have this block and we have this block here. Now this block will experience a normal reaction due to this one, and which is equal to the normal reaction, because there is equal and opposite reaction. So when you push this with a force of 20 newtons, it will act on this one. Hey, move it. It's like pushing this block to move. But remember, according to Newton's third law of motion, if it's pushing this block to move this way, action, there's equal and opposite reaction. A normal reaction to push this one to go the other way. So the normal reaction acting on this one will be called N, which is the same as this force acting here. So we just call it also N, the action force. We just call it N because it is equal to the normal reaction force. Now we need to find the normal reaction. Now remember here there is 20 Newton acting, and remember this system is moving at an acceleration of 10^3 meters per second squared. Now we have it from Newton's second law of motion again. The net force equals to mass times acceleration. We can use this block here, right? So this block here, the net force is 20 minus N, right? 20 newtons minus N equals to, wait, this newton should not confuse with N. Let me remove it here, not confuse. Equals to mass. What is the mass of this one? 4 kilogram times 10^3 meters per second squared, right? This is 20 Newton, this is just N for normal reaction. So what do we do here? So we'll get 40/3, 20 minus normal reaction equals to 40/3. I want to write newtons here but it will confuse us with this normal reaction. I write it at the end, right? Okay, so I rearrange this one to be 20 minus 40/3, which is equal to 20/3 newtons. So therefore the normal reaction equals to 20/3 newtons. Okay, so that is our normal reaction force. Okay, let me put these papers properly. So that is how we solve these questions. Let's see another example. Okay, we are told 3 blocks of masses 3 kilogram, 2 kilogram, and 1 kilogram are placed side by side on a smooth surface as shown in this figure. Okay, a horizontal force is then of 12 Newton is applied. Horizontal force of 12 Newton, you can see it is applied on this 3 kilogram block. Find the net force on the 2 kilogram force. So we just need the net force on the 2 kilogram force. Okay, how do we solve that question? Simply we start finding the acceleration first, as in the former question. So I won't talk much here, I'll just go straight forward. To find the acceleration, let me write it on this side. From Newton's second law of motion, we say net force equals to mass to acceleration, right? So that's the net force here. It's just 12 Newton acting on this whole system. We treat this as one whole thing. 12 newtons equals to the mass here. 3 plus 2 plus 1 is 6 kilograms times acceleration. So simply acceleration will be 12 Newton on 6 kilogram. Acceleration will then be equal to 2 meters per second squared. Okay, so that's clear. Now we do not want acceleration, we want the net force. So where did we find acceleration? Easy. We have the acceleration, we have the net force 12 kilogram, which is acting even to the 2 kilogram force. We have the mass, right, of which is 2 kilogram force. So that means you have the net force acting on this 2 kilogram force. Okay, so you need net force on the 2 kilogram force, on the 2 kilogram mass, right? Now remember, from Newton's second law, we were told net force equals to mass times acceleration, right? Easy. So our net force here, or even I can use this one, sum of F, but I want to use it here so as you do not confuse with this one. Equals to the mass is 2 kilogram. The body has a mass of 2 kilogram, but it is moving at what acceleration? 2 meters per second squared. Easy. So simply the net force then becomes 2 times 2. I think I need to use a calculator for that. Okay, 4 newtons, right? I think I'm correct. 4 newtons. So that's the net force, 4 newtons. Very simple questions. Okay, now I think you have understood. Now let's see this question. No, I actually mean look at this question. This one. Try to solve it. Two blocks of masses 5 kg and 2 kg are pulled by a string with that force of 40 newtons horizontally, as shown in the figure below. I didn't show you the figure, but I think you know how the figure looks like. Okay, we have this. Okay, and we have two blocks here. Two blocks, maybe they are tied to maybe like a string. Okay, and then okay, they're tied to something like a string and then pushed. Oh, sorry, this the string is horizontal, aligned horizontal, because if it's inclined, that's something else which you'll see in other videos. The force is 40 newtons. The force is 40 newtons horizontally, as shown. Remember, I said they are pulled, right? So that's why the string, this whole thing is tied to the string and it's pulled this direction. Find the net force on 2 kg block. Now you need to find the, now I think you know this is the 5 kg block, this is the 2 kg block. Find the net force on the 2 kg block, this one, and the normal reaction between the blocks. Easy. So I want you to try this one, and if you get the answer, put them in the comment section below. I'm coming to check it. Thank you very much. See you in the next video. Good luck.